Okay, here we are choosing an exponential model and using it to make a prediction. So we see the data points show the amount of Y in milligrams of a radioactive substance after decaying for time X. So our X-axis represents the time in days, and our Y-axis represents the total amount of this substance in milligrams. So we see it's decreasing at an exponential rate. It says each figure has the same data points. We see we have the same dots. However, each figure has a different curve fitting the data. The equation for each curve is also shown. The equations for this particular curve, you see this here is linear, and these are exponential. Answer the questions that follow. Well, which curve fits the data best? We don't have to make this too complicated. Intuitively, we look, well, which curve is hitting most of the lines? We see that this one only represents what might be consistent with this dot up here. This curve isn't touching any of these up here. We're allowing this this data to skew the curve. And this one is touching most of the curve, or most of the data points there. It's touching all of them actually. It doesn't go straight through the middle, but it's fairly consistent there, touching all of them. So we see that figure 3, like I said, let's not overcomplicate it. It hits most of the data points. Use the equation of the best fit line, that would be this one here. Best fitting curve, from part A to predict the amount of radioactive substance after 50 days. 50 days is our x-axis, so we would plug 50 in for x, our variable. So we've got y is equal to 546 times 0.98 raised to the 50th. So it looks like we started with 546 milligrams. It's decaying because we see that the number here is less than 1, so it's decaying, and the days we want is 50. Let's see how much substance we'll have left after that. I'm going to go ahead and put my calculator in here and see if we can see that. I'll move it to the side. So how would we put it in? We would just say, well, order of operations tells us parentheses first, so we can't simplify inside the parentheses, so next would be exponents. So we would take 0.98 and we would raise it to the 50th power. That gives us this decimal, and then finally, after we've done that, then we can multiply, because PEMDAS tells us parentheses, exponents, then multiply. So we would multiply this answer by 546, which should give us what's remaining after 50 days. So they want us to round. It says round to the nearest hundredth. So the hundredth place here is the 3. We see that the number next to it is a 6, so we would round up. So instead of 1.98 or 198.836, we would have 198.8, and then instead of 3, we would round up to 4.